Over the course of the last year, you've actively investigated a series of themes related to the new hardware movement. What's the state of those themes?
Well, the big thing that we're seeing across the whole movement is that hardware is getting more accessible. So it's getting cheaper and it's getting easier to use. And that puts it within reach of a lot of people who might not have been able to use hardware to develop innovative hardware before. So you don't have to be an electrical engineer with a big budget to do something cool with hardware. You can be a person with a small budget, sort of a generalized technical background, like a lot of software developers and designers have, and do cool stuff with hardware.
What are some of the specific developments you're seeing?
Well, so around the end of last year, beginning of this year, we saw a handful of really inexpensive embedded computers become available. So there's one called Chip that's $9. That made a big splash last fall. And then the Raspberry Pi Foundation has announced the Raspberry Pi Zero, which is $5. This is a pretty capable little computer that's about the size of a stick of gum, and you can put it anywhere. At $5, you don't have to have a crazy budget. You don't have to know exactly what you're getting into. You can just start to buy these things and experiment with them. It's bringing this kind of rapid software mindset into the physical world where it hasn't really been able to exist before.
And what are some of the surprises that you're seeing in these spaces?
So the big surprise in this area to anyone who's done a lot of embedded computing and microcontrollers and stuff is the accessibility. So you're starting to see higher level programming languages on embedded systems. You used to have to program embedded systems, which is a computer inside some other machine, like it's the computer inside your washing machine, inside your car, inside an industrial controller. These things used to be so underpowered that you had to program them really efficiently in like C or assembly. Those are kind of tough languages to use. But now we see people programming this stuff with JavaScript, which is incredibly accessible, and Python, which is a language that kids learn in middle school. So the barriers to usage are coming down. And that all derives from the improving power, the improving energy efficiency of these devices, which is itself a result of smartphone development. So all these chips and all these components are really smartphone components. They're making it into other kinds of computers now.
So lower cost, accessibility. What are some of the other on the horizon topics that you're watching in these spaces?
Sure. So a few interesting products have come out, a few interesting developments from companies in the area have come out. One is the Amazon Echo has really been an impressive device that a lot of hardware innovators are looking at. This is a small computer that sits on your kitchen counter and takes voice commands and then does things like reads you the weather, adds things to your shopping list, turns on and off your lights. It's really opened up a lot of possibilities for new kinds of interfaces. And Amazon has also created something called the Alexa voice service. They've basically made the core sort of interaction intelligence engine, the voice recognition and speech engine inside the Echo available to any developer who wants to use it. So it's kind of emphasized this idea of hardware as an endpoint to software. The exciting stuff isn't just that people are making hardware, electronics, and putting them out there. It's that if you have some software system, you can develop hardware that's a new endpoint for it. So Amazon already had this very sophisticated ability to understand consumer preferences and interact with people. And then it created Echo, which puts that capability on your kitchen counter. I think we're going to see a lot more stuff like that, especially as developers and creators take advantage of tools like the Alexa voice service.
How do you see that playing out over the long term, like next 2 to 3 years? We've got Echo, and I remember when Echo first came out, a lot of people were kind of like, it's cool, but I don't know what this thing is. But now it's starting to make sense. So if that starts to make sense now, I mean, how do you play this out?
Well, this is an idea that we've been talking about here for a while called design after the screen. As computers become more ubiquitous, they start to find their way into everything around us. We're actually going to have to interact less with screens. So it's kind of silly if you have a Hue light bulb system in your house, these internet connected light bulbs. You're turning them on and off by like opening your phone, opening an app, hitting a button. We've seen from the beginning that is a really silly way to operate your lights, right? Yeah. And so for a long time, we've been looking for a revolution in design beyond the screen, where you're controlling lights by speaking to them, or you're controlling lights by setting your preferences early on and then having a computer act on them. So lights go on when I get home, right? And you don't touch your phone, you don't touch a light switch, it just happens. So the Echo is a really big step in design after the screen. I think we're going to see a lot of new products that are very sophisticated with that kind of design thinking. In terms of the commercial landscape, Amazon is one of several big companies that have really impressive voice engines. We haven't seen anything like the Echo emerge yet from Google, which has Now, Apple, which has Siri, and Microsoft, which has Cortana. But all of them are undoubtedly watching Amazon and thinking about what their next move is going to be. So we'll look for products, services to come out of them. There is a Cortana voice service that developers can use. There's not really one for Siri or Google yet, but both of them have put a lot of resources into those services, and you can bet that something is going to come out. And then in startups, I think we'll see more companies taking advantage of these services, building on top of the platforms, coming up with really good user experiences.
Do you see these developments primarily happening on the consumer side, or is there an industrial side to it as well?
The industrial side is really exciting. There are a lot of people working on it. Worker productivity is one of the big areas that could benefit from this kind of interaction. If you're a repair person out in the field and you're trying to fix a piece of power transmission equipment, it would be great to speak to a service driven by Cortana or Amazon or Google or Apple and say, hey, what is this part? How do I order a replacement? Or how do I connect this part to this part? And it looks up the information in a giant ream of documentation and reads it to you clearly. So that's also a big application for augmented reality that people are interested in. Companies like DAQRI are working on helmets that show employees readouts about sort of system information on a little screen in front of your eyes, so that while you're repairing a piece of machinery or working on an industrial plant, you have relevant information in front of you.
So last question for you. You mentioned augmented reality before. What is the difference between augmented reality and virtual reality, and which of those two do you feel is most promising?
That is a great question. The difference between augmented and virtual reality is that in virtual reality, you're completely immersed in a 3D environment. You're moving around it. In augmented reality, you're looking at the real environment, but the system is overlaying some amount of virtual material around it. So Google Glass, for instance, is more of an augmented reality thing, though it's not fully augmented reality. Microsoft HoloLens, for instance, is augmented reality. You're looking at the room around you, but little flags are popping up and labeling, for instance, the camera, the chair, and telling you about it, giving you opportunities to go deeper. So it's an overlay. Now, I think the promise of augmented reality is perhaps more revolutionary. We're used to the idea of virtual reality, of going into these immersive environments, and in gaming, there's a lot that people will do outside of gaming with productivity and surgery and things like that. But augmented reality is a bit more revolutionary, and it's a much harder challenge as well. We had a great conversation about this with Rob Conybeare on the O'Reilly Hardware podcast a few weeks ago. He's an investor in hardware. He was one of the first investors in Nest, and now virtual reality is one of the areas that he's really interested in. And he pointed out that in virtual reality, if you create an environment that has some stutter in it, that has a flaw in it of some sort, that hangs a little bit, that has a little latency, it doesn't rip you out of the environment immediately. But in augmented reality, if you're moving your head around and the augmented element, the pin that's supposed to stay over Mac's head, lags a little bit and falls off of Mac's head, then the illusion is ruined and you're snapped back out of it. So augmented reality is going to take a lot more computing power, a lot more sophisticated sensors than virtual reality. But the promise of it is terrific and is only beginning to be explored.
Great. Well, thank you for joining us. Appreciate it.
Of course. Thanks, Mac.